As we begin this final video that will focus on the parts of a wave, I want to take just a moment to consider a statement found in the upper right-hand corner of our note sheet. A wave is a periodic disturbance that transfers energy but not matter. In other words, it is the energy that has transferred from the left end of the slinky or rope across to the right end, but not the particles of the medium or the matter itself. Note that for the transverse wave, the sphere is only moved up and down. The yellow, however, illustrates the fact that it is the energy that the wave carries that moves across the entire length of the rope from left to right. Similarly, the slinky coils only jiggle left and right a very small amount. Note that the white, however, indicates that when one coil hits another, it transfers kinetic energy to an adjacent coil. And it's this energy that moves rightward throughout the whole slinky. Well, let's come back to our journals and jot down some of a wave's anatomy. And we'll look at the transverse wave first. The highest points of a wave are called the crests. The bottom parts of a transverse wave, illustrated with the green dots here, are called troughs. The distance from one trough to the next adjacent trough is called a wavelength. And we use the Greek letter lambda, symbolized like an upside-down Y, to represent this. A wavelength actually could be the distance from a crest to the next adjacent crest, or any place on a wave until we get to the next point on that same wave. For a longitudinal wave, we see places where the coils are packed together, and those are called compressions. The places where the coils are least packed together, or least dense, are known as rarefactions. And again, the distance from any compression to the next compression, or from a rarefaction to the next rarefaction for that matter, is called the wavelength. Now there's one other term that's really important both for a transverse and a longitudinal wave. It's how much the particles of that medium have been displaced or have moved from their rest position. That's known as the amplitude. For a transverse wave, it's shown that as the distance from the center line to a crest or the center line to a trough. For a longitudinal wave, it's shown as the distance that any one of those coils is displaced to the left or to the right. Now, why don't you take a moment, jot these down in your journal, and when you're ready you can hit play again and we'll consider a question. Why don't you consider this question, and when you're ready you can answer parts A and B below.